So here they want us to find angles that are coterminal, meaning that they're pointed in the same direction. So 142.1 degrees. Remember, the initial side starts on the positive x-axis, so this is 0 degrees, 90 degrees, 180, so 142 will be kind of in this direction. 142.1 degree. So if we're coterminal, then we're going to be a complete rotation from that angle. So we would go a complete rotation to get back there. So from 142.1 degrees, we could go forward a complete rotation. And that would get us to, what's that, 502.1. We could go forward 2 complete rotations. So if we went forward another complete rotation, we would still be back to here. If it was more than a complete rotation or less than a complete rotation, then it would not get us back to this side. But if we point any direction and go all the way around, then we're back in the direction we started. So if we add another 360, that would get us to 862.1 degree. So both of those angles are coterminal with 142.1. Now, if we want some negative angles that are coterminal, then we just rotate in the other direction 4 rotations. So if we rotate counterclockwise, that's positive. So if we rotate clockwise, that's negative. So let's erase that. So if we want to rotate in the negative direction, we would start here, rotate, and if we go all the way around, it gets us back to the same direction. So from where we start with, if we travel 360 degrees in the negative direction, that would get us back coterminal. And 142.1 minus 360, get my calculator out. Oops. $142.1 minus 360. That gets us to negative 217.9 degrees. So that's an angle that is coterminal. If we subtract another 360, then that would give us an additional angle that's coterminal. So that would get us to negative 577.9 degrees. So all 5 of these angles are coterminal, meaning they're pointed in the same direction. If we rotate and where we stop rotating is in that direction, we could get there by making any of those rotations. All right, so now talking about having a line 6x plus 5y equals 0 that goes into the second quadrant. Notice it goes through the origin because if x is 0, y is also 0. So that line, something like this. If we were to solve that for y, we would get y equals negative 6 over 5x. Negative 6 over 5x. So if we go to the left 6, we would go up 5. So that's a point on that side, to the left 6, up 5. So they want us to find sine, cosine, and tangent for that particular angle. So this is the x-coordinate, this is the y-coordinate, and we could also get the radius. The radius squared is the x squared plus the y squared. So if we square the x coordinate, we get 36. If we square the y coordinate, we get 25. Add those together, that's 61. So r is the square root of 61. So that's r. So if we want sine of theta is y over r. So 5. You know what? That is rise over run. I did it as an ordered pair. The r is correct. But -6 over 5 is rise and run. Sorry about that. So that means we would go down 6 over 5, or we would go up 6 and to the left 5. Both of those would give us points on that line. So to be in the second quadrant, we would be up 6 and to the left 5. Rise over run. So our y is not 5, our y is 6, and r is root 61. Or we could rationalize that. Cosine is the x coordinate over r, so our x, we're to the left, so -5, and our r is root 61. And then tangent theta is y over x, so 6 over -5, or we could just call that -6/5. So that'll give us sine, cosine, and tangent for that particular direction. Just that's not the only point that we could use on that terminal side, but by using that slope of that line, that makes it easy to come up with an ordered pair that's on that line. And to get sine, cosine, and tangent, we need an x, a y, and an r. So by using that ordered pair, that allows us to plug into our new definitions. Okay, so this one, they tell us that cotangent is 5 in the third quadrant. So we have some ray whose terminal side is in the third quadrant. So our angle is theta. And cotangent for that direction is 5. Now remember that tangent of an angle is defined as y over x, which means that cotangent is defined as x over y, because cotangent is the reciprocal of tangent. What does this help us with? Well, if we know a ratio for cotangent, that will give us an x and a y that's on our terminal side. So if we pick a point, draw a point in the third quadrant, we need an x value of 5 and a y value of 1. But wait a minute, if x is +5 and y is +1, wouldn't that be in the first quadrant? Well, yes, it would be. But notice, if we're in the third quadrant, we're to the left and down, so x and y would both be negative. Notice if we put a negative on top and a negative on bottom, 2 negatives would make a positive. So this point would be to the left 5, down 1. To the left 5, down 1. Our reference triangle would be here, with an x of -5, a y of -1. And then we could get our r. So -5 squared plus -1 squared equals r squared. So r squared is 26, or r is the square root of 26. So once we have those, we can get our other trig ratios. So sine is y over r, so -1 over root 26. Cosine is x over r, so -5 over root 26. Tangent is y over x, so -1 over -5, which is also +1/5. Two negatives make a positive. We could rationalize those denominators, or we could leave them like they are. So just by knowing one ratio and knowing our definition for that ratio, we can come up with a point that is on our terminal side. All right. Now they want us to find the reference angle and an exact value for our function. So 225, we need to figure out what direction that is. So here's 0, 90, 180, 270. So 225 would be between 180 and 270. So that's in a direction of 225. So from here all the way to there, 225. Now, it asks us for the reference angle. The reference angle is always measured from the horizontal. So this angle would be our reference angle. So notice, if we take away this part, we would be taking away 180. So if we have 225 and we take away 180, then we'd be left with theta, which would be 45 degrees. So that's our reference angle, 45 degrees. So one thing that we'll learn is that angles that have the same reference angle will have the same ratio. So cosine of 225 will have the same value as cosine of 45 degrees does. The only possible difference will be the sign, the SIGN. So if we think about a reference triangle that is a 45-degree triangle, our reference triangle has sides of 1, 1, and the square root of 2. This is our reference angle here, theta. So cosine from our reference angle is adjacent over hypotenuse, or when we rationalize that, that's root 2 over 2. That's for 45 degrees, but for ours, our x is to the left, our y is down. So if we use x over r, the definition of cosine is x over r. Our x is negative, our r is positive, so we would get negative root 2 over 2. Oops. So notice cosine of 45 and cosine of 225 have the same fraction part, but they have different signs. In the first quadrant, cosine is positive, but in the third quadrant, cosine is negative. Why is that? Because cosine is x over r. R is positive. If we're in the third quadrant, x is negative, so that would make for a negative ratio. Same reference triangle, but since we're in the third quadrant, x is negative. Okay, now they ask us for cosecant of negative 180. So let's draw a triangle. Or I'm sorry, let's draw maybe a triangle. Let's draw a grid. So if this is our initial side and counterclockwise is positive, then negative 180 would be here. That's rotated in the negative direction 180 degrees. And we're asked to find cosecant. So we just need to pick a point that's on that side. Any point will do. So if we're to the left 3 units, we're up and down none. If we're to the left 3, we're up and down none. We could pick any point to the left, but we'll still be up and down 0. Cosecant is the reciprocal of sine. So with this definition, sine is y over r. Cosecant is the reciprocal of that, so cosecant is r over y. Well, what is our radius? The radius is the distance from our point to the origin. Well, if we're to the left 3 and not up or down any, then our radius is 3 units. That's how far we are from the origin. So a radius of 3, a y value of 0, that makes that undefined. Undefined. So in a direction of negative 180, the ratio for cosecant is not defined. All right. It also asked us about the reference angle. Remember that a reference angle is measured from the horizontal. Well, if we are on the horizontal, then our reference angle is 0 degrees. All right. Zero degrees is in this direction. So the reference angle, if we're on the horizontal, we have a reference angle of 0 because we're not rotated any from the horizontal. So if we want a value for cosine in that direction, we pick any point on that side. We can use 4, 0 or 5, 0. If we go to the right, we don't go up on 0 degrees. The definition that we're using now for cosine is x over r. If we're just straight to the right and not up or down any, then that distance is our radius. So cosine is the x coordinate over the radius. So cosine is 1 in the direction of 0. So regardless of what point we pick there, let's say we call that distance A, or if we're to the right A and not up or down any, then the radius is also A. A over A will be 1. So regardless of where that point is, the x and the radius are going to match. Anything divided by itself, it's 1. Okay, here we just want to know about the signs. What are the signs going to be for our values in each of these, or in this direction? So we need to find out where is negative 237. So if we rotate in the negative direction from the initial side, here's negative 90, negative 180. If we went all the way to this direction, that would be negative 270. So negative 237 is before we get there. This would be negative 180 degrees. This would be negative 237 degrees, or 270 degrees, sorry. So negative 237 would be in between there. In the second quadrant, we're to the left, so x is negative. We're up, so y is positive. So if we're asked about sine, remember sine is y over r. In the second quadrant, the y is positive, the radius is positive, so we would get a positive answer for sine. Cosine is x over r, so in the second quadrant, x is negative, the radius is positive, so cosine would be negative. Tangent is y over x, so y is positive, x is negative, so tangent would be negative. So X, Y, and R let us know if we're going to be positive or negative in each quadrant. All right, here's a word problem. Let's take a look at this. It says we have an airplane that flies 200 kilometers in a direction of 230 degrees. So if it says in a direction of 230 degrees, that's considered to be clockwise from north. When we're given headings, they're measured from north, and they're measured in a clockwise rotation. So if we start, if north is here, and we rotate clockwise, this will be 90, 180, 270 would be there, so somewhere over here. So from north to there, it's 230 degrees. And that distance is 200 kilometers. So we want to know how far west have we gone. So if we think about a reference triangle right here, we could think about that triangle having a west component and a south component. We've gone to the left some. If we fly that direction, we've gone over some and we've gone down some. So we're looking at how far have we gone over? How far have we gone to the left, which for our purposes is west. It's also good to write an N there as a reminder that that's north. So if we imagine taking this part away, from north to south is 180. So if we take 180 away from 230, then we're left with this part. So that would give us an angle here of 50 degrees. The angle inside our triangle here is the complement of that. So that would be 40 degrees. Another way we could look at this is that our reference angle is measured to the horizontal. So from here all the way to there is 270. If we take away this part, the part that is not our reference, that's the 230. So if we take away 230, then what we're left with is the reference angle in there. So 40 degrees is the reference in there. So I'm going to sketch that little triangle. This is a right angle. West and south are perpendicular. This angle is 40 degrees. I'm going to label this side W for west because that's what we're looking for. So we know this side is 200 kilometers. So from 40 degrees, we're looking for the west side, which is adjacent, and we know the hypotenuse. So we could say that cosine of 40 is the adjacent side divided by the hypotenuse. If we multiply both sides by 200, then those would cancel. So west is whatever we get there when we do 200 times cosine of 40. And that has to be in degrees. So about 153. That's in kilometers. So that's how far west or how far to the left we've gone. Okay, find the approximate value of cosecant 483. Well, if we put out a calculator is only going to have sine, cosine, and tangent on it most likely, and then the inverses. So if we need to find cosecant of 483, we need to ask ourselves, what is that going to be related to? Cosecant is the reciprocal of sine. So if we know sine of 483, cosecant is the reciprocal of that. So if we take sine 483, clear. If we take sine of that, for sine we get 0.8387. 0.8387. That's the value of sine. Cosecant is the reciprocal. So how do we get a reciprocal? There's a little button on our calculator that says 1 over x. So once we calculate sine of 483, we can hit that 1 over x button, and it will give us the reciprocal of that. When we see 1 over something, think about x as being some random number. If we write that as a fraction, that would be x over 1. Well, what would the reciprocal be? The reciprocal would be 1 over x. So that's what that 1 over x button does. It gives us the reciprocal of whatever x is. So if we calculate sine of 483, and then we take the reciprocal of that, we get 1.1924. 1.1924. So we do not take the reciprocal of the angle. It's the ratios that are reciprocals. So we get the ratio for sine, and then we take the reciprocal of that. This one asks us to find a value for theta, knowing that cosine theta is negative 0.9336. Now, if we type in our calculator and use the inverse cosine of our ratio, it's going to give us an answer that's probably not in the quadrant we want. If we take 0.9336 to make it negative and take inverse cosine, I get 159 degrees. So in this case, it is. In this case, the angle that they give us is in that interval. If they give us one that is not in that interval, then we would use the reference angle. For example, if they said instead of between 90 and 180, if they say between 180 and 270, so in this direction, notice cosine is still negative because anytime the x-coordinate is negative, cosine is negative. Cosine is related to the x-coordinate, so if x is negative, so is cosine. So 159 is in this direction. If we take that away from 180, that'll give us our reference. So if we do 180 minus 159, we get a reference of 21 degrees. 159 is 21 degrees from 180, or 21 degrees from the horizontal. So if we're asked for an angle theta in the third quadrant that has that ratio, we want to know what angle in the third quadrant has a reference of 21 degrees. Notice that would be 21 degrees past 180. That'd be 21 degrees past 180. So from 180, we rotate past it, so add 21 degrees. So that angle would be 201 degrees. If we took out our calculator and took cosine of 201 degree, if I could type it in there correctly, cosine of 201 degree, we would get negative 0.9336. So this angle and this angle have the same value, the same ratio for cosine. Why is that? Because they have the same reference angle. Their reference angles match. Why do they have the same SIGN? Because they're both to the left, so both of them have an x value that's negative. Cosine is x over r. R is always positive, so if cosine is negative, if x is negative, cosine is negative. All right, let's do one or two more. This is the last one. So again, we run into the problem that we don't have a cosecant button on our calculator. If we did, we would do inverse cosecant of 3.8637, and we would find out what angle has that ratio for cosecant. But we don't have an inverse cosecant button. But we recall that cosecant and sine are reciprocals. If we know sine, we know cosecant. Or if we know cosecant, we know sine. This time we know the ratio for cosecant. We know the ratio of cosecant. So we can translate that and say, well, if I know that cosecant is 3.8637, sine is 1 over 3.8637. So if I know the ratio for sine, then theta is inverse sine of that ratio. So it's the ratios that are reciprocals. So if we do inverse sine of that ratio, 1 over 3.867, 8637. That's our ratio, and then we're going to do inverse sine, and that gives us an angle of 15 degrees. But wait a minute, we're looking for an angle between 90 and 180. 15 degrees is in the first quadrant. So how can we get an angle in the second quadrant that's between 90 and 180? Well, first of all, is that possible? Here, our ratio for sine is positive. Is sine positive in the second quadrant? Well, sine is related to the y-coordinate. Remember, sine is y over r. So if the y is positive, sine is positive. And guess what? In the second quadrant, y is positive. So yes, it is possible. What do they have in common? They have the same reference angles. So our calculator gave us the angle 15 degrees, but we wanted the angle in the second quadrant that has that same reference angle. If it has the same ratio, then it has the same reference angle. So the angle we're looking for is 15 degrees before you get to 180. Remember, 180 is here, so that 15 degrees is before 180. So 180, go backwards 15 degrees, and that would get us to 165. So that's the angle we're looking for. So the big things here are understanding reciprocals and understanding reference angles.